Okay. So here we have the index we are going to follow for this webinar. We are going to start with self-powering concepts. Then we are going to speak about Fanox self-power relays families, explaining their main applications. And we are going to be focused on Siab relay with a specific and standard CTs. We will explain also the communication software that is called Sikim, and we will finish with some main concepts and self-power relays advantages, including the references and approvals for these relays, and we will finish with some questions and doubts. In this slide, we can see Fanox self-power relays. In the first line, we can see the Siab relay, and in the second line, the Siac relay. Okay, before starting, we are going to clarify the concept of self-powering. This concept defines the supplying mode for electronic protection relays for medium voltage, and it means that there is no need for auxiliary supply to power the relay on, and the energy is obtained directly from the line that we are protecting. The main differences between self-power relay can be separated depending on the CTs that we are going to use. We have standard CTs that are CTs that provide a secondary equal to 1 ampere or 5 amperes, and the specific CTs. These CTs are going to provide some special feature respect the standard CTs, like a higher saturation level or a wider measurement range. In case of the relays that work with CT standard or standard CTs, the relay must manage the extra energy provided by the CTs. In this case, the only characteristic that the CT should comply is to provide the necessary VAs, in case of Fanox relays less than 2 VAs, and complying this feature, the user can install any CT in the market. So it is not possible to know the energy that the CT will provide to the relay. For this reason, this type of relays are usually bigger than the one that work with specific CTs. In case of specific CTs, the design is performed in pack. This is, we are going to design the relay along with the CTs. So the CTs are prepared to give to the relay exactly the VAs the relay requires. In this case, we don't need to manage any extra energy, so this result in a smaller relays comparing with the one that work with the standard CTs. Then I will show you the relays and you can see the differences in the size. Other important question that can come to our minds is which opening mechanism will be used with self-power relays. As I told you, these relays are going to be powered up through current. So in these cases, the energy is scarce. So using an ideal or appropriate opening mechanism is very important. In this case, it is used the low power coil or a striker. This is a very simple device. It requires really low quantity of energy to be tripped. And in case of Fanox relay, we can ensure that we are going to trip any striker in the market, because all the relays are provided with a setting called trip voltage level. With this setting, I am going to tell to the relay which is the voltage level my striker needs. Here we can see some examples of the striker. Fanox can provide its own striker, but also can ensure that we are going to trip several strikers in the market. Here we have some examples used by Siemens, Lucy, ABB, Schneider, just some examples. Before starting with Siab relay, I wanted to show you just a very brief summary about self-power relays that we can offer in Fanox. We have two models that work with standard CTs, Siac and Siab, and a special model of Siab that work with specific CTs. In all the cases, we are going to have local communication through the front port and also remote communication through the rear port. The relays can work as pure self-power relays, just with the current, but optionally, we can also use external power supply if there is voltage in the installation. The relays are overcurrent and are fault protection relays with ANSI code 50 and 51 for phases and for neutral, but also we can include some other functions if we need in the installation any advanced protection. Finally, we have to consider that the relays are provided with configurable outputs and inputs. If we speak about the applications of self-powered relays, we can separate or we can consider two different important applications. One is the renewable energies. In this case, the relays are very compact, so they are very useful because the switchgears in this type of application are really small. In case of photovoltaic installations, the ideal Fanox solution is the Siab. Why? Because as you know, in this market it's really important to use a really competitive and easy relay. In this case, we can mention some applications from Siemens, Eaton, or some utilities in the world as Oman or Vietnam. In case of wind power, we usually use the standard Siab. In this case, we can find this relay in two applications. It can work as the main protection of the installation, or it can work as a backup protection. If the main protection loses the power supply, we will have the self-powered relay to protect against short circuit and air faults. Other important applications are focused on RMUs and smart RMUs. These switchgears for secondary distribution differ from each other mainly by the available communication. The relays for smart RMUs are provided with remote communication to connect with the SCADA system. In this case, using a Fanox self-powered relay equips the installation with an intelligent solution, providing communication, selectivity, or data recording that we cannot have if we protect the installations with fuses. Then I will show you both relays to show you the differences in size, in protections, and everything. Okay. After having more or less clear the concepts of self-powering, of the specific and standard cities, we are going to start to explain Fanox Siab relay that work with specific cities. This relay is an overcurrent and air fault protection relay. It works with specific cities, and it can work as a pure self-powered relay, just with the current from the line, or we can use also external supply in case it is available in the installation. The minimum self-powering level that we need to switch the relay on is 3.2 amperes, and the relay is also provided with internal commissioning battery. This battery is only used to check information or to set the relay. It is not used to trip or to protect the line. So in this case, if we remove the battery, the relay will work completely in the same way. All the relays are provided with non-volatile RAM memory to store up all the information the relay can record, up to 100 events and 4 fault reports. In this way, we can be sure that when the relay is switched off, the information will be in the relay permanently. We are not going to lose any information when we don't have external supply. The protection functions that are included in a Siab relay are the overcurrent and air fault protection, also the external trip, thermal overload, trip lock for switch disconnector, and programmable logic to program and to configure the inputs, outputs of the relay. In regards to the power supply, as I told you, we can work with the relay with all the functionality as a pure self-powered relay, just using the current of the line. We can also use the auxiliary supply in case it is available in the installation. Through the front port, the mini USB, we can use a standard cable, and being connecting the relay to the laptop, it will be switched on automatically. Also, we have the internal battery. Just remember to check information and to set the relay. And thanks to this USB port, we can use a standard power bank. The relay is provided with a USB to communicate locally, and also is provided with rear communication to communicate remotely, thanks to the port RS485. The relay is provided with 2 configurable outputs, and the trip output is prepared to trip the low power coil or strikers. Also, we can check on the front 2 LEDs and 1 magnetic flag to signal the trip has occurred. In this case, maybe I can show you the relay. This is the Siab for specific cities. You can see it's a really compact relay because we are going to work with specific cities. So the cities have been designed to give exactly the energy the relay needs to be self-powered. Okay?
Okay.
Okay. So if we check the front of the relay, apart from the LEDs, the front USB, or the magnetic indicator, we also have a keypad and a display in order to be able to navigate through all the menus, to check information, to set the relay. In terms of specific current transformers, Fanox can offer 2 different mechanics depending on where these CTs will be installed. The tape CTs are useful or are designed to be installed directly on the bushings of the RMU, and in case of the epoxy resin type, they are designed to be installed on the cable. And just to remark the importance of the communication in this type of relays, I just wanted to repeat that we are providing front communication through the USB port with the protocol Modbus RTU, and also rear communication to communicate with the SCADA with a RS485 port, also with Modbus RTU protocol. Okay, this relay that we have explained at the moment is the one that, as I told you, we can use in the RMUs, but it's very typical to use also in applications of photovoltaic systems due to its competitive price, its easy functionality, and considering the importance of the competitive solution for this type of market, make the Siab from Fanox the ideal solution. Okay. After understanding the Siab with specific cities, we are going to explain deeply the Siab with standard cities. In this case, we also have an overcurrent and airfall protection relay, and also it can work as a pure self-powered relay only using current, or a dual power using the external supply if it is available in the installation. In this case, we will work with a standard current transformer with a secondary equal to 1 ampere. The only characteristic that we have to consider for these cities is that they should provide at least 2 VAs. From this value onwards, any CTO in the market will be valid. The minimum level to self-power the relay, if we inject in single-phase situation, we need 160 milliamps in secondary or 75 milliamps in primary, in 3-phase, sorry, also in secondary. And in the same way as in the previous relay, we are going to have an internal commissioning battery. In the same way, this commissioning battery is just included to make easier the process of checking information and setting the relay. If you don't have any power bank, if you don't have auxiliary supply or a laptop to switch the relay on, this battery allows the user to switch the relay on just to check and set information. For sure, we are going to include also the non-volatile RAM memory, just to be sure all the information will be in the relay permanently. In this case, we have improved the information that the relay can record, and the relay will record up to 1,024 events, 24 reports, and 10 oscillographic records in complete format. All this information, then we can see how easy it is to analyze using the Sikim software. The protection functions that are provided with this relay is our overcurrent and airfall protections, but also second harmonic blocking, external trip, phase balance to analyze the imbalance that can occur in the installation, thermal overload, low load pickup, breaker we are monitoring, circuit breaker failure, zone selection interlocking just to make the selectivity, trip lock for switch disconnector, and the necessary programmable logic to configure the LEDs, the outputs, and the inputs to signal the requirements from any user. In regards to the power supply, we can work as a pure self-power relay, just with current. We can also use external power supply, in this case, universal power supply from 24 to 230 AC DC. Also the micro USB connected directly to the laptop or a standard power bank. As in the previous case, we have local and remote communication. Local communication through the front USB with the protocol Modbus RTU, but in case of real communication, we can select the protocol between Modbus RTU or the MP3. The relay is provided with 3 configurable outputs, the trip output for the low energy coil, and 3 configurable inputs. And on the front part, we can see that we have 4 LEDs. In this case, if we see the front part, you can see that we don't have any magnetic indicator, we don't have flags, but the reason is because the LEDs that we have included are intelligent, they have memory. So once the relay is switched off, when you switch it on again, they will signal exactly the previous state before the fault. So we are going to see in the LEDs the reason of the trip. They are totally configurable, so you can signal with them whatever you need. Apart from this, we are going to have the keypad and the LCD, the display, to navigate through the menu, to check information, to set and configure the relay. Everything, or all the things that we can do with the relay, we can do with the Sikim. So then when we explain the communication software, we will see how we can do with the software and with the relay. And as in the previous relay, just to remark the importance of the communication, just remind you that we have the front communication port, micro USB, to communicate locally and also to switch the relay on directly with the laptop, and also the real communication, the RS485 port, with a protocol selectable between Modbus RTU and the MP3. So just to show you this relay, this is the other relay, the one that works with the standard CT. You can compare the size with the previous one. Okay, you can see that it's bigger, but the reason, as I told you, is because this relay needs to manage any extra energy that can come from the CTs, because we don't know exactly what our clients are going to install. And this is the relay that is used for smarter end use with real communication, and also for renewable energies for the wind power. Okay, I think these relays are more or less clear, but because they are similar but they have important differences, I have prepared this table very briefly to compare the features of each relay. The main difference, of course, is that the one Siab is going to work with specific CTs, the other one with the standard CTs with a secondary equal to 1 ampere. Both relays can work as pure self-power relays, or in case in the installation it is available, we can use external supply. We will use also the internal battery to check information, or just a normal standard cable connected to the laptop to switch the relay on and to communicate simultaneously. The relays are provided with configurable outputs and inputs. The protection functions over current and air fault by default, but in case you need to add any advanced feature, any advanced protection functions, we have the imbalance, the second level of protections for overcurrent and air fault, the call-out pickup, the trip lock, the communications in both cases local and remotely, the information recording, events and fault reports, but you can see that in Siab with standard CTs, the number of recordings is improved, And also we have the possibility of having oscillographic records. Both relays are provided with non-volatile RAM memory to be sure the information will be permanently recorded in the relay. And we have the programmable logic to configure the relay depending on our requirements. Okay. The software. In this case, you can download the software from the website. It's totally free. And the main advantage is that if you run the program being connected to internet, it is updated automatically. You don't need to uninstall the old versions. It will be updated once you run the program. So let me share this icon and we will see how it works. It's very friendly, so you will see it's easy to work with it.
Hi, Maitane, you have more or less 20 minutes more.
Okay.
15, 20 minutes, okay?
Okay, perfect. Now, the icon is very easy, so are you seeing the icon, Sonia?
Yes, yes.
Okay. So, first of all, we press start. The relay is only connected through the USB, okay? So it is powered up. The icon recognizes directly the associated port, and I insert the password, 5555. I press OK. And the icon is going to be starting. Okay. So the main screen is only a screen to give us some information regarding the relay, the model, the firmware version, the serial number, the explanation of each digit of this model, states, measurements, and counters. On the top, we can see the different menus that the relay is provided with. So pressing on them, we can see the information of the states, for example, with this yellow triangle to tell me something is activated inside, in this case 50 Hz, ready, and local communication. If I go to the settings, I can press on its protection function and I can set the necessary levels to protect the installation. So, for example, I can change the values and we can see some yellow triangles on the right side. This means that I have changed something in this icon, but I need to send them to the relay. So once I press send settings, I have a message telling me the settings sent successfully. Now these settings are recorded in the relay, okay? Also, we have the events where I can check all the information that is recorded in the relay. Okay, so let me show you how we will analyze a fault or how we can check the information the relay has recorded. Just some seconds. Okay. So this is all the information the relay has recorded. We can see some pickups and trips for overcurrent protection, but also we can see any of the information that the relay can record. For example, if I change a setting, we have the event. If I synchronize the relay, I have the event. So sometimes having the events is a little bit complicated to analyze exactly the fault, okay? So for this reason, we have also the fault reports. These events, because there are many events, can be saved in a file and can be analyzed later when we leave the installation. So to analyze exactly the fault, the trip, we have the fault reports, okay? In this case, we are going to have only the events related with the trip, related with the fault. So it's easier to analyze what happened in the installation on this regard. So if I open one, in this case we have 9 fault reports, we can have up to 20. But here you can see it's easier because I only have the trips and the output. Here we can see the level of the current that was measuring during the fault and the date and time at the moment of the recording, okay? So the events record all the information, the fault report only the events related with the fault. And in this case also we can have these fault reports graphically represented thanks to oscillographic records. So in this case, if we go to the contract, we can see here that we have 10 oscillographic records. It takes some time to be downloaded. So meanwhile, just to not be here just checking how the oscillographic record is recorded, I am going to show you how to navigate through the menu. Okay, you can see that here we have the relay just connected with the USB. I don't know if you can see my screen of the relay, but it's very easy. I press OK and I have the menus to navigate. Okay, so
yes, we can see.
Sonia, can you see it?
Yes, we can see, yes.
If we want to set a setting, we can press OK in this menu. For the protection functions we want to configure, for example, overcurrent. Okay, I press OK. I press OK to change. I have to insert the password because in the Sikim we insert it at the beginning, but here I have to insert when I want to change a setting. I insert 5, 5, 5, 5. Okay, and now I can change the permission, for example, to disable it. I can change the tab, okay, or the time.
Maitane, if you can go to the back just to see better the screen of the relay. Yeah.
Yes, like this?
Yes, more or less, yeah.
Tell me, I don't know if you can see it. Okay, so just to show you the process is very easy. Everything that we can do with the Sikim, we can do with the relay. Okay, so we can change settings, we can go back and go, for example, to the events, to analyze the events. Here we have all the events that the relay had recorded. Also, with the Sikim, I'll go back and I can go to the, for example, fault reports. Okay, so here we will have several fault reports. Pressing OK, I can enter inside to analyze the events that are recorded in the fault reports. So the only thing that we cannot check with the relay is the oscillographic record, because the oscillographic record is the graphical representation of the fault. So it is not possible to check in the relay, but we will check it in the Sikim. So let me show you, because it is this chart. This is the representation of oscillographic records with the current that are involved in the fault and the signals that have been activated during the fault. The good idea of this is that here we have a representation, but we can save this information as a contract format that is a standard format, and you can open with any visualizer in the market. Okay. So you can see that everything that we can do with the relay, we can do with the Sikim. It's very intuitive. Also, we can synchronize the relay. Okay, to put the date and time according to the date and time of the laptop. And also, we could select a specific date and time. Okay, so you can see that the Sikim is very easy, the relay is very easy. And in this case, it is important to mention that sometimes you want to set the relay before having the relay in your installation. So this Sikim has the option to work offline. Okay, just very briefly, if we go to File, New, we can prepare a setting file. For example, now we are working with Siab, okay? We select the model that we are going to use. For example, this is the typical one for RMUs. We press OK. And here we are going to have a template of all the settings of the relay. Okay, so we can prepare the file, we can save it, and when we have the relay in the installation, we can send this file to all the relays. So the templating is generated. Okay, so here we have the general settings, all the protection functions. Okay, the template is generated with the default settings with everything disabled, but you can change whatever you need. You save this template, and then when you have the relay, you can send the settings to the relays. Okay. So
we have, can you hear me?
Yes.
We have a question now that you are with the Sikim.
Yes.
A question about one of our applications for example, wind farms. How we can change through different group settings.
Okay.
With the digital inputs. Can we, for example, make an example
Yes.
with the Sikim?
Of course.
Okay.
Let me connect again. I closed it. It's opening. Okay. So this was the Sikim, okay? I go and say it again. Yes, because that application is very useful. It's very typical to have different settings group with different settings for the maintenance task and for operation. So it's typical to prepare different tables, and in the installations, usually there is a switch to change from one table to the other. So in configuration, we are going to be able to configure the outputs, okay, that by default they are going to show us the general ready, the phase trip, and the neutral trip. Some seconds, okay, so this is the watchdog situation, the relay is not ready, the phase trip, and the neutral trip, okay. If we go to logic, we have two signals that are called setting group 1, and setting group 2. In this case, if we open them, we can configure them to be activated with the input. For example, setting group 1 for input 2, and setting group 2 for input 3, for example. Okay, here we have a message that we have changed something here, but we need to send to the relay. So we would send the new configuration to the relay. And in this case, when the input 2 is activated, the relay will work automatically with setting group 1. And when we activate the input 3, the relay will work automatically with setting group 2. So in the settings, we will have settings prepared for the setting group 1 and settings prepared for the setting group 2. Yes, it's clear?
Yeah, I think so.
Okay. Anyway, if some of the doubts are not clear because we don't have all the time that we wanted to have, we can prepare some emails and we can continue working on this.
No, but by now it's okay. We are answering, and then we summarize the most common doubts.
That's it.
Because you are with the Sikim.
Okay, perfect.
Okay.
Okay. So okay, so just to finish with the presentation, we wanted to share with you some companies that are using Fanox relays. So in this case, we can mention, for example, Eaton, Snyder, Lucy, or Masabal, ABB, G&W, Alphanar, FASEC. So you can see that Fanox relays are very commonly used. And also, we wanted to share with you some approvals that we have for this type of relays, utilities in the world like Iberdrola in Spain, Ka Electric in Pakistan, ENA in UK, Tabanir in Iran, Saudi Electricity Company in Saudi Arabia, Adwia in Emirates, Tenaga in Malaysia, Pemex in Mexico, Edenor in Argentina. So you can see that these relays are used around all the world, and we have installed thousands of units of self-power relays. And finally, I just wanted to clarify some advantages of Fanox self-power relay and some main concepts, just to be sure the idea of the self-power relays is clear. So just to consider the differences between self and dual powering. The self-powering is the capacity of the relay of being switched on through the current. External supply is not required. And dual powering is the capacity of the relay of being switched on through external supply. So in this case, if there is external supply available in the installation, we can work with the relay as a standard CT. But if we lose this external supply, the relay will continue working with the current of the line. Other important concept in self-power relay is the switch on to fault situation. This is the capacity of the relay of tripping from a dead state. Consider that when the relay trips, the line is open, and when you close the line, you need to be able to wake up very fast to measure the current to detect if there is a fault and to trip as fast as possible to protect against short circuits. So the switch on to fault is one of the main characteristics of the self-power relay. The lower this time is, the better the self-power relay is, and we can ensure we have one of the fastest self-power relay in the market with a switch on to fault time around 50 milliseconds, really fast. And finally, we wanted to mention some special advantages that we can offer with self-power relays. One is the external trip input without auxiliary supply. We know the majority of the relays in the market are provided with this input, but sometimes they require external voltage to activate this input. For us, this is something that does not make sense because we are working with relays that are self-power because the auxiliary supply is not warranty or it's not present. So having something that requires auxiliary supply, it's a little bit contradictory. So for us, external trip should work without auxiliary supply. Also, the importance of having non-volatile RAM memory, because the relay after the trip are switched off, so we need to be sure the information will be in the relay permanently. Apart from this, the self-power relays are overcurrent and fault protections, but due to the importance of the communication and other protection functions that are incoming very typical, we have self-power relays with advanced protections and advanced communications. And it's important to mention that all the functionality is available in the relay in self-power mode. We don't need any external device or any external power supply to have the advanced functionality. And finally, this is the situation that we have tried with the Sikim, and is the advantage of having several settings group, because it's very typical that the client needs to set several settings depending on the application or depending on the situation. For example, some typical application is to have different settings group for maintenance tasks and standard operation. So I think at the moment, it's a good moment to start with the doubts. First of all, I wanted to share with you a poll that we have prepared just to know your feedback or your opinion about this webinar. So I'm going to launch it. And also I wanted to remind you that if you have a icon, so my colleagues will see if you have any specific doubt, and we can enable your microphones.
Yes, in the meantime, maybe I summarize one of the main questions. For example, there is a question that if power is lost, okay, what happens with the communications if we have the battery? So I think we should clarify that the battery is not is only for commissioning. I mean this topic.
That's it. Yes, the battery was only included because sometimes when you go to the installation, if you don't have a power bank or you don't have a laptop, you don't have the possibility of switching the relay on to check the information. So we included this special battery just to make easier the process of switching the relay on, analyze the events, the fault report, or if you need to change any setting. But not for the normal functionality, communication strips. The battery does not participate in this part of the functionality of the relay.
Okay, perfect. And another question is why the user should choose between the specific cities or standard cities.
Okay, in this case, the situation is if you, sometimes the specifications of the utility is telling us what type of cities we need to use. We have some countries and some utilities that they declare we need specific cities or we need standard cities. In case this is not mandatory, you have to consider one is the space of the switchgear where you are going to install the relay, because as I told you, when we use specific cities, we are going to have a more compact relay because the design of the cities is exactly done for the relay. In case of standard cities, the relay can be a little bit bigger. So we have to consider the space where the relay should be installed. And apart from this, sometimes the specific cities give us the advantages of cover more primary currents. As you know, with the standard cities, I have a primary and a secondary, and we don't have any possibility of changing this. With the specific cities, with one city, we can cover several primary currents. So depending on the installation, depending on the specification, and depending on the requirements, we will study the most useful application in this case. I don't know if it's clear or you have more doubts on this.
Yes, we have one person that wants to participate. Okay. Okay. So I'm going to give permission. Okay.
Okay.
Yes.
Hello, everybody. Thanks very much for such an interactive session. I'm Saeed from Sims, Pakistan, and we are using so many relays, Siac here, the self-powered relays. I had a question which I tried to clarify earlier as well, because we are bound to use the special type, not really the special, I would say the type tested CTs in our switch gears. So for us to use the so-called the cost saving, I would say, the CTs, or who are only compatible to the special version of the relays. It was my question, can't I use those special, the normal CTs which I use in the switchgear like 5P20 or 10P10 with the relay? Do I really need to change the model of the relay in this case?
Yes, if you want to work with specific CTs, you need to change the model, because the SIAC only can work with standard CTs.
But for Siab, we need the special CTs from the Fanox, right?
Yes,
that's so my question is, what really is the, let's say, the science or the knowledge behind this, that the standard CT would not power up the Siab relay? Suppose if I am having the Siac relay somewhere installed in the switchgear, and the Siac relay gets faulty, and if I go to change it with the Siab relay, then I will not be able to do so because of the mismatch of the CTs. So
Okay.
what is really stopping me to do this? Okay, you have developed the CTs, fine, but in the end, it's a current which is feeding the relay. This is my.
Okay, so you want to maintain the CTs and to change the relay, right?
Yeah, exactly.
Okay. And in this case, if the CTs are with secondary equal to 1 ampere, you can use the Siab with the standard CTs. But in case the CTs are 5 amperes of secondary, in this case, we should change CTs and relay.
Okay, this is understandable. The nominal output should be the same, either 1 ampere or it should be consistent with the relay. Except from this CT secondary current, there is no parameter to be taken care of, like the burden of the relay or other things. Sorry,
Yes.
burden of the CTs.
Yes, no problem. If you the burden of the CTs that the Siac requires a bit higher than Siab with standard CTs. So if you have the CTs for Siac relay, the burden will be valid for Siab relay also, but only with the standard CTs. Because in case of specific CTs, the burden that is required by the relay is really low, less than 0.1 VAs, and it is because it is designed according to the relay. So in Siac, the burden is a little bit higher, 2.5 VAs. In Siab with a standard CT, 2 VAs. With this characteristic, we can use any CT in the market.
Okay, good. There is another point to be clarified. In the Siac relay, there is also an option of the low power tripping. Like in order to trip the breaker, if I am having a potential transformer, I can use the CTU and then I can trip the vacuum circuit breaker.
Yes.
But in some cases, I don't have even this capacitive trip unit. So does the relay give the tripping power from inside circuitry? Is it also possible in Siac relay? In normal scenario, if I'm using the self-powered relay,
yes,
I don't have the auxiliary DC or the AC available.
Okay.
So I use the current, the capacitive trip unit.
Yes.
The CTU, which gets charged by the potential transformer. And then in case of the tripping, we trip the breaker through this capacitive trip unit. The question is, if I don't have even this CTU, I want to save this current, this capacitive trip unit and the potential transformer. Is relay capable to give enough energy to the vacuum circuit breaker to trip it? Is this option available in the relay?
Yes, in this case, when you close the line and there is the current will be power the relay up, and the relay will protect or will treat against the short circuit.
Okay, and the relay will close its, let's say, normally open contact to the normally closed. Okay.
Yes.
Change the state, and it will then energize. It has to energize the trip coil of the vacuum circuit breaker.
Yes. In this case.
Okay. Where will this power be coming from? Because I don't have any auxiliary DC or AC in the panel.
Okay. Okay.
So is relay capable to give this power?
An adapter that is called TCM, that is just an energy accumulator. So it's a typical application to install with the relay. So when we don't have any AC/DC and the relay has not energy, this energy accumulator gives to the relay the necessary energy to trip the coil. Okay, but we will need an external device that is called TCM.
Sorry, please come again. Could not get it.
Yes, in these relays, TCM, trip circuit monitoring, is just an energy accumulator. So when it is charged, it can store up to 72 hours of energy to help the relay to trip.
Okay, and it
yes,
and it needs to be ordered separately.
Yes, we have to order it separately. Yeah. Let me take notes, and I will send you information on this regard to clarify and to give you the information. Okay.
Okay.
Thank you, Sayed.
Okay, thank you very much.
Thank you to you.
Okay, maybe we can launch again the poll if somebody hasn't answered yet. Okay.
Okay.
So we have like 5 minutes more.
Yes, if you have any other doubt, if you want to repeat something that it's not clear.
Yes, maybe one question that we have been answering, what happens if we have a conventional tripping coil? Can we trip?
Yes. Yes, in this case, in the majority of the situation, of course, if we have a conventional tripping coil, we are going to have auxiliary supply. So this is not a problem because our relays are dual power. So we can take advantage of this auxiliary voltage to switch the relay on and also to trip the coil. Anyway, if we need to trip a coil in a self-power mode, the only thing that we have to consider is that we cannot use the usual trip output that is designed to trip a striker. We need to use any of the signaling outputs. They will be configured as for the trip, and we can trip the coil. And for these cases, just to trip once or twice, it's not a problem because the relay is going to have energy. But if we have a switch on to fault situation and the fault is permanent, it's not transitory, we need more energy to trip several times. In this case is where we can use the TCM, trip circuit monitoring. That is our device that, as I explained, is an energy accumulator, and it will give to the relay the necessary energy to continue tripping the coil.
Okay. Okay, more or less a few like not deep explanation, but key points how to select a specific city.
In which conditions?
I mean, from the
SIAB.
From the different specific cities that we have.
Okay, the model. Yeah.
Yeah.
Okay, maybe I can share again the slide. What is where it is explained?
Yeah, maybe.
The different cities. Okay, so let me. Okay. I don't know. I think you can't see anything, right? So let me.
You can see the presentation.
Okay, so here we have several cities. The mechanic is clear. We are going to select it depending on where these cities are going to be installed, okay, on the bushings or on the cable. And then we have several cities with different EM nominal ranges. Okay, so here, depending on the primary current of our installation, we will select the city where our nominal current is included inside. This is, if my nominal current is 10 amps, I will select CT8, okay? If the nominal current is 60 amps, I can select the CT16. So I need to select a CT that covers my nominal current with the explained range. You can see that are some nominal currents that are included in several CTs. For example, if I have 20 amps, I can select CT8 or CT16 because 20 amperes is included in both ranges. In this case, it is very important to keep in mind which is the minimum level that I need to have the relay self-power, okay? Because the level of self-power is defined in times the nominal current. So if I want to protect from really low values, I will select the smallest CT. And if I want to protect higher values, I can select the CT16. And other things that it's more or less useful in these cases, because several CTs are valid for many currents, it's very typical to select the same CT for different considerations. This is, we have examples or clients that tell us, I want to protect with the same CT from 300 kVA up to 1,500 kVA. For this reason, we can consider the different nominal current and select, in this case, for example, CT16 that covers all the currents. But the main concept is to know the nominal current of our installation and select the CT where our nominal current is included inside.
Okay, I think it's clear now.
Okay.
Well, I think it's time.
Yes. Yes, so I think we will share the presentation, but I hope this information that we share with you have been clear, useful, and can clarify some of your doubts. Of course, you have our contacts, so you can contact me or my colleague Sonia in any time if you have a doubt, if you need something from Fanox. We are really grateful of receiving your news, and we will support you by email or by phone or what you need.
Thank you very much, Maitane, for the presentation.
Thank you.
And all the questions that are arising now in the chat, please send by email, and we will. Okay, well, maybe we have maybe last question, very brief, Dennis.
Okay.
Okay.
Hello, everyone. Hi.
Hello, how are you?
Good, good. Just quick one. This is regarding the nominal current of, and this is regarding the relay, how the relay will behave if the nominal current is less than 3 ampere. I just want to understand the behavior of the relay when it is less than 3 ampere.
Okay, in this case, if the nominal current is less than 3 amps, we cannot work as a pure self-power relay because this is the minimum current that we need to switch the relay on. So having them less than 3 amps only will be valid if we have also auxiliary supply. Okay? In this case, if we have an auxiliary supply, we can protect less than 3 amps, around 2 amps or something like this, but we have to be sure that the relay is not going to work as a self-power. In this case, because all the protection functions are set in times the nominal current, we will set the nominal current in the relay and we will set the protection functions according to this value. But always keeping in mind that because the 3 amperes is the minimum required level to switch the relay on as a self-power relay, if we have lower current than this, we always need external supply to switch the relay on.
Okay. With the auxiliary supply, can we be more specific what exactly the current it starts protecting with auxiliary supply? Is there any more?
Auxiliary supply, the relay can protect the minimum current is 0.2, the minimum of the CT. So in this case, we can protect from 1.6 amperes. This is the minimum with external supply that the relay can protect. 1.6.
So in that case, you will use a specific CT if SAB that specific CT version. I mean the 085 or the other one.
Yes. This is just with 0.85 because it's the CT with the minimum range.
Mm-hmm.
So with CT8, we can protect with external supply from 1.6 amperes.
Yeah, thanks for the clarification. Without auxiliary supply, if I use the CT0805,
yes.
What is the possibility of short circuit protection? I think you said that SOTF is still possible and it will trip. I believe that short circuit protection will be applicable less than 3 amperes.
Yes, in this case, the maximum current the relay is going to measure is 20 times the maximum of the relay. So the short circuit, 560 amps. This is the maximum current the relay can measure without saturation.
Okay. Thanks for the clarification. I'll ask separately if there are more queries on this. Thank you.
Okay, thank you. Anyway, the relay will support more current, but because the functions are going to set in times the nominal current, this is 20 times and are 560 amps. Okay?
Yeah, thank you.
Okay.
Thank you, Denise. Okay, so I think that now we can finish.
Okay, so once more, thank you very much for your assistance. It's been a pleasure to share with you all these concepts that we hope it is useful and interesting for you. And as I told you, anything you need, you can contact us, email or phone or whatever you need.
Yeah, thanks to you, Maitane.
Thank you.
Bye.